So today we are reviewing Pythagorean theorem, which you did extensively in 8th grade, but that's been a little while. So, what is the only time we can use Pythagorean theorem? What kind of shape has it got to be? It's got to be a right triangle. And what do you use the Pythagorean theorem for? What are you finding? The missing sides. So, it is used to find the missing sides of a right triangle. Okay? So I gave you a figure here, and then I asked you sides A and B. Sides A and B, those refer to the sides that make the right angle itself, and those are called the legs. Side C is across from the 90-degree angle, and what do we call that? Hypotenuse. Now, you could probably go to a random adult in the grocery store and ask them, what is the Pythagorean theorem, and what are they going to tell you? A squared plus B squared equals C squared. That might be the only thing they remember about math. They might not even know how to use it or what it's used for, but it's stuck in their brain. Okay? So the Pythagorean theorem is A squared plus B squared equals C squared, and the main thing that you have to do is get the hypotenuse in the right spot. If you get that C in the right spot, it's going to all work itself out. Alright, so I started you out with a couple of easy figures. Alright, your directions say find the value of x and round your answer to the nearest tenth place. Now, let's talk about... If I give you this number. Alright, so I'm going to make up a random number. I've got 98.37201. If I want the tenth place, what digit is in the tenth place? 3. Alrighty. And so to round, you look right next door. And I always say, 5 or more, raise the score, 4 or less, let it rest. What's a 7 going to do to this 3?
Plus 1.
Alright, so you're going to get 98.4 approximately. So I use approximate because I round, and it's not a perfect answer anymore. So if I gave you 132.7145. Now, which digit is in the tenth place? In my new number. Tenth place is the first, and so what is 1 going to do to that? 4 or less lets it rest, so it would just be 132.7 approximately, okay? If I said the hundredths place, that's the hundredths place. You're going to have to do something that most people don't do, which is read the directions and see where you need to round it to. Alright, but for here, I want you to round to the tenths every time. So now I'm going to focus on number 1. Oh wow, that's, what is in its mind too. Alright, I need to find x, that's this side, okay? Is that missing side, it is part of a 90-degree, or right angle, a right triangle, so I can use a squared plus b squared equals c squared. Am I missing a leg or the hypotenuse? So that means this is c. So these are a and b. It really doesn't matter if I let this be a or this be a. Okay, so I'm just going to call this one A, this one B. And I'm going to set it up so that I have A squared plus B squared equals C squared. Now, C, I can replace that with my X because I now know what that is. I know my X. Now, a lot of teachers, especially when you were learning Pythagorean theorem, another standard in the 8th grade was that you know your perfect squares. We're past that. I'm going to work smarter, not going to make you. Alright, so now that we have our a squared plus b squared equals c squared set up, I was saying before the computer lost its mind, I had to restart everything, that when you were in the 8th grade, their standard was to make sure you knew these perfect squares. That's not my problem, okay? At this point, you either know them or you don't. I need you to quickly be able to calculate that. So, here's what I honestly do. I'm going to take this side, and I'm just going to do 8 squared plus 13 squared, and that's going to give me 233 equals x squared. I just do the math right there. I let my calculator work for me. Now, here's the students notoriously mess up. Does it even make sense that if this is 8 and this is 13, that this will be 233? No. I have x squared. I want x to be unsquared. How do you unsquare x squared? I'm going to take the square root of both sides. When I do that, I'm going to type that in. The square root of 233 is not the right thing if you don't type it. There we go. All right, that helps me know. Plus my directions told me to turn it into a decimal to the tenths place, so I'm going to use the double arrow. Now, the 2 is in the tenths place. What is a 6 going to do to my 2? It's going to round it up to be a 3. And I'm going to use the approximate symbol because I did have to round, and so no, it's no longer exact. What you need to realize for further, like future calculations, if you round this, it's a little bit off. If you use that number and round it again, it's a little more off every time. Okay, so that's why we use the approximate. All right, so here's what I want you to do. I was finding my hypotenuse in this one. My x, what are you finding, a leg or a hypotenuse in number 2? You're finding your hypotenuse the same way. So here's what I want you to do. I want you to find that hypotenuse, and I'm going to tell you that your final answer should end up being 34.8. So I want you on your own to find that hypotenuse. All right, so here's my work. You took leg squared plus leg squared. Now I did 27 squared plus 22 squared. It absolutely does not matter if you did 22 first. What matters is that your hypotenuse is over there by itself. And so when I added these two, I got 1, 2, 1, 3. I take the square root of both sides so that I get x, and then I ended up with 34.8. All right. In the next number 3, find your x. Here's your x. Am I asking you to tell me a leg or a hypotenuse? A leg. What is your actual hypotenuse here? The 9, because it's across from the 90-degree angle. So you get that set up. X squared plus 7 squared equals 9 squared. You could have done 7 squared plus x squared. Your legs have to be together. Your hypotenuse needs to be by itself. Now, you could absolutely go ahead and write that 7 squared is 49 and 9 squared is 81, but you're just going to subtract it anyway, so I like to work smarter, not harder. I'm going to get rid of add 7 squared by subtracting 7 squared. And so I get x squared equals, now let me type that in to make sure I get the right numbers, because it's not 9 minus 7. It's 9 squared, which is 81, minus 7 squared, which is 49. That gives me 32. I need x equals. Do you have x equals? Nope, you've got x squared. How do you unsquare? You take the square root. So the square root of 32. Now, that gives you 4 square roots of 2. So x is exactly equal to 4 square root of 2. If you needed the exact answer, that's it. But I asked you to give me the tenths place. So let me turn it into a decimal. The tenths place is this 6. What is 5 going to do to that 6?
Make it a 7.
Make it a 7, so it's going to round it up. The math is not hard, as long as you get everything in its place. All right, so I want you to do the same thing with number 4. Looking at number 4, are you finding a leg or the hypotenuse? Talk to me. Is number 4, the x, is that a leg or the hypotenuse?
Leg.
That's a leg. What is your hypotenuse? Across from the 90-degree angle is right here. I want you to solve that real quick. I'm going to go ahead and put what you should end up getting so you can check your answer. All right, so real quick, you would have set this up as 19.1 squared plus x squared equals 30.5 squared. And can I give you a word of caution? Make sure you don't forget your square. Okay? Because when I used the decimals earlier, I forgot the square, and what happened to my answer? It was all messed up. Okay? So then I minus the 19.1 squared from both sides. And I ended up with 565.44, and so I had to take the square root. And And that's how I ended up with that number right there. Okay? Alright, so Pythagorean theorem. If I give you an easy little triangle, I don't expect you to have any problem. Where I expect you to maybe start second guessing yourself is when I give you figures that I've cut into pieces. Okay? But remember, what is the absolute only time you can ever use the Pythagorean theorem? What kind of triangles?
What triangle?
Has to be a right triangle. You have to be guaranteed and know for a fact it's a right triangle. You can't assume anything. Alright, so let me zoom in my attention on number 5 here. Number 5 is asking me to find x. This is x that it's referring to right here. That is called the altitude of the triangle. So what I need to know is basically how tall is that triangle. Tell me what I already know about this big triangle. If this is 24, that's marked the same, so that's also 24. Okay? I've got 2 right triangles when I drew this altitude. You can look at either one. I'm going to look at this one. Is x a leg or a hypotenuse of this triangle that I'm focused on? Talk to me. It's a leg. What is my hypotenuse? Do I know my hypotenuse? All right. So C is 24. I can't do Pythagorean theorem because I don't know this amount. Is this tiny amount 22? 22 is the whole thing. And altitude, if you remember, cuts it in half. So if this is cut in half, what's this side? And then this side is. So now, solely focus your attention and pretend like this is the only right triangle in the room. Okay? How are you going to find x? You're going to use Pythagorean theorem. You're going to use x squared plus 11 squared, and that's going to equal 24 squared. You want x by itself, so you're going to minus 11 squared from both sides. And you're going to do 24 squared minus 11 squared in your calculator, and that's going to give you 455. How do you unsquare something? You take the square root. Now, let me put that in my calculator. Alright, square root of 455. Turn that into a decimal. I want the tenths place. So what is the 3 going to do to this 3? Nothing. So your x is approximately 21.3. Alright, number 6. When you just look at this, are you given a straight up right triangle? Just there's the right triangle. No. You're given this weird little figure. And you're asked to find this side, this x. Okay? Now, I know it's Pythagorean theorem. I know I should be able to use the Pythagorean theorem, but I don't have a right triangle. You could draw a line, and you could make a right triangle. Where could you draw one line and know 2 sides? You can't draw this way. You know why? You only know one side. That doesn't help you. Okay? If you draw this way, you ain't even got a right triangle. If you connect this line, these 2 lines, this x is the same length as this x. 18, though, goes all the way across. Is this side 18? No. From here to here is 5, so this is 5. How do you find this little piece? 18 minus 5 is 13. So what you're working with, imagine, tune out everything else. You've got 13, x, and 16. Which of those is your hypotenuse? Because you just created a right angle. 16. So, a squared plus b squared equals c squared. And now you subtract your 13 squared, you start solving. So when I solve, 16 squared minus 13 squared gives me 87. How do I unsquare this? Take the square root. Now, let me grab my calculator. The square root of 87 turned into a decimal. I need the tenths place. So 3 is in the tenths place. What is the 2 going to do to the 3? Nothing. 9.3. And I'm going to change this equal to approximate because I did round it and I don't want anybody to think that's exactly what it is. All right, let's look at number 7 here. Okay, so if I'm looking at number 7, I see a giant triangle. Is this marked as a right triangle up top? Nope, so you can't assume. Even if it looks like it, it's not. You need to find x, which is actually this entire bottom. But you can't do 14 squared plus 29 squared because this is not a right triangle. You do, however, have 2 smaller right triangles. Since this is a right triangle, so is this. I need to find these 2 smaller pieces, and then what will I do with those? Add them together. So, focus your attention on this smaller triangle right here. This 14, 12, and this side. Do you know the hypotenuse? What's the hypotenuse of this smaller triangle? 14, so that's C. So I'm going to call that a squared plus 12 squared equals 14 squared. And so I'm going to subtract 12 squared from both sides. A squared equals, I typed 14 squared minus 12 squared in my calculator, and I got 52. How do I unsquare that? I take the square root. And so A is approximately square root of 52 turned into a decimal is 7.2. So from here to here is 7.2. Now, when I look at this other triangle, that's a leg, that's a leg, that's the hypotenuse. So I'm going to do 12 squared plus b squared equals 29 squared. You know why I didn't use x? X is the whole length on the bottom. So I'm going to minus 12 squared from both sides. B squared equals 697. How do you unsquare b squared? You take the square root. So the square root of 697 turned it into a decimal. Round it to the 10th place. What's a 0 going to do that for? Nothing. It's going to keep it the same. So it's approximately 26.4. So from here to here is 7.2. From here to here is 26.4. So what are you going to do to find x? You're going to add those together. And when you add those together, x is 33.6.